the derivation of expression for Kc. So Kc, it is a new term to you. Let's have a look how we can derive the value of Kc. Kc, it is known as the chemical equilibrium. So for the derivation of Kc, we have to consider a hypothetical reaction or a general reaction. For example, a reaction in which we have A moles of A reactant. It is going to combine with the B moles of B reactant, and after the reaction we gain the C mole of C product plus the D mole of D products. Here the small letters A, B, C and D, they are going to show the number of moles, where we have C, A, B, C and D. These are the moles, and we have A and B. These are the reactants, and here we have B, we have C and D. This is, we can write it as, we have C and D. These are the products. So this is the simple description about that. This double arrow is going to show that this is a reversible reaction or a general reaction. Clear? Next, now we have to derive the value of Kc. Now what does mean by Kc? I will tell you at the last of the lecture, but first we have according to the law of mass action. So according to law of mass action. So this derivation will be done according to the law of mass action. According to law of mass action, we have the rate of forward reaction. Rate of forward reaction is directly proportional to the molar concentration of reactant A raised power to the A, and the molar concentration of B raised power to its moles, that is B. If we are going to remove the proportionality constant, then we can get Kf proportionality constant into A, and then we have B, where it is going to shown by the rate of forward reaction as Rf is equal to Kf and molar concentration A, its moles A, and molar concentration B raised power to its moles B. So this is the first equation. Next we have for the reverse reaction, likewise or same, rate of rate of reverse reaction, it is directly proportional to the molar concentration of C and D. So molar concentration of C, each raised power to its number of moles as C or its exponent, then we have the second product as D and its number of moles as D. By removing the proportionality constant, we will get rate of reverse reaction is equal to K R and C its power C and D moles as D. Now by removing the rate of reverse reaction or replacing it with the R, that is rate of reverse reaction is equal to Kr and C concentration and its mole C and D concentration of the product and its mole D. So this we have the second equation. Now how we can find it out? Let's have a state of equilibrium. At equilibrium state, we have a look, and when we are at equilibrium state, then rate of forward reaction, it becomes equal to the rate of reverse reaction. So from the equation 1 and 2, or by putting the values, we will get that RF is equal to RR. The rate of forward reaction is equal to rate of reverse reaction. So by putting the values from RF, we have KF A concentration and its moles A, and the reactant B and its moles B. It is equal to KR, which is C reactant and its moles C, and we have molar concentration of D and its moles D. So this is the equation. Now by rearranging this equation, what we will get, as we are going to done it for the hypothetical reaction. So by rearranging the equation, I am going to write the equation again as Kf A moles and B moles. It is equal to rate of reverse reaction, that is C into mole C and D into moles D. So by rearranging this, by rearranging, we get Kf over Kr is equal to C, as this is the rule of math, D and D, by moving the concentration on one side and proportionality constant on one side. C and A into A and B its moles B, where Kf over Kr, its ratio, the ratio of proportionality constant for the forward reaction and to the proportionality constant of the reverse reaction, we have Kf over Kr is equal to Kc, where Kc, it is the equilibrium constant. Kc, it is the equilibrium constant. The C is going to denote the constant for the reaction. So by putting Kc over Kf over Kr, we get Kc is equal to C and D. These are the products, and A into moles A into concentration B into moles B. These are the reactant. So in turn, Kc is equal to the products concentration molar and to the molar concentration of the reactants. So this was the simple derivation of Kc for the hypothetical reaction. Next we have the definition for the Kc. Now what does mean by the Kc or the equilibrium constant? We can write it by a simple formula that Kc is basically the ratio of product of concentration of the products, and it is raised to the power of coefficient. Coefficient means its number of moles, and the product of concentration of reactants, and each raised to the power of its coefficient, or we can say that the number of moles. Simple answer is that, or the Kc, basically it is the ratio, and ratio of the product of the concentration of products. We have the concentration of products in the numerator and each raised power to its coefficient. Coefficient mean here we have shown the number of moles, and in the denominator we have take the concentration of the reactants, and each concentration of reactant must be raised power to its coefficient. So this was a simple chemical equilibrium or equilibrium constant derivation. I hope you guys understand about this. And if you have any queries, you can ask me about that in the comment section. For that time, have a good day and Allah Hafiz.